Good evening, students. So আজি আমাৰ চেপ্টাৰটো হৈছে চেপ্টাৰ ষ্টাৰ্ট কৰাৰ আগত বা লাইভ ক্লাছ ষ্টাৰ্ট কৰাৰ আগত নেচেচাৰী থিংছ কিছুমানৰ কথা I want to talk about the necessary things. So what are the things? First of all, you need to have a notebook, pen, pencil লাগিব, then a bottle of water so that you can drink while you study, and a clear mindset. You need to have a clear mindset so that you can understand well and things to do. Feel free to comment your doubts in between the lecture. Okay, please like and share in Facebook if you enjoy the video. Then I'll try to clear your doubts as soon as the live session ends. Then do not forget to comment positive words so that they will make you as well as me positive, and we can carry on with our learning process. And the last but not the least thing, pay attention to what I speak from now. So let us begin. So today's chapter is chapter number class 10 science, chapter number 12, electricity. So you will find in page number 199, and this is the first video, and write the date and class number before starting. So content of this chapter, what we are going to learn in this chapter, so you need not write it down or note it down, just pay attention. So we are going to learn about electric current, what is electric current, and we are going to learn what is circuit. Then we are going to learn electric potential difference, what is electric potential and what is electric potential difference. Then we are going to learn what is circuit diagram and symbols. Then we are going to learn what is Ohm's law and resistance. Then we are going to learn the factors on which resistance depend. Then resistance of a system and resistors. These are the things or topics which we are going to learn in this chapter. Okay, and this video will be of 30 minutes, and we will cover as much as we can in this 30 minutes. Then we'll continue in the next day, and I will be giving live videos on Tuesday, Thursday and Saturday, that is TTS, from 7 regular from 7:30 to 8 there will be live class. So again, the topic we are going to learn is heating effect of electric current. You need not note down these topics, okay? Then we are going to learn the application of heating effect, and at last we are going to learn what is electric power. We are going to learn what is electric power. So let us begin with the chapter. The name of the chapter is electricity. Okay, and the first topic which you have to note down is electric current. Electric current. Okay, so before knowing what is electric current, we have to know what is charge. We have to know what is charge. Okay, so now what is this charge? It is a property of matter. I hope you have learned what is matter in class 9. Anything that has mass and occupies space is matter. Okay, and charge is the property of matter. Charge is the property of matter. That means it is a property of matter. Then there are two types of charges. There are two types of charges. We already know this. One is positive charge and the other is negative charge. Okay, there are two types of charges. One is positive charge and one is and the other is negative charge. Again, as it is a physical quantity, we need to measure the physical quantity, and to measure physical quantity we need a unit. For example, to measure mass, the unit is kilogram. To measure temperature, the unit is Kelvin. These are all physical quantities. Similarly, charge is also a physical quantity. That is why we need a unit, and the unit of charge is coulomb. The unit of charge is coulomb. Okay, so next we are going to learn these things. Now, what is electric current? Okay, when charge flows through a conductor, we say that there is an electric current in the conductor. I repeat, what is electric current? Electric current is when charge or charges flow through a conductor, charge or charges flow through a conductor, we say that there is an electric current in the conductor. First of all, before knowing what is electric current, we have to know what is current. What is current? Okay, flow of anything is called current. For example, if water flows, we say there is a water current. In river, water flows, so we say there is a water current. And when air flows, we say there is a flow of air, and that is wind. Moving air is called wind. Okay, similarly, when charges flow, we say that when charges flow in a conductor, we say that there is an electric current in the conductor. Okay, you need to note down this definition, not definition, a description of what is electric charge. Next, we are going to learn what is electric circuit. Okay, what is an electric circuit? So electric circuit, it is a continuous and closed path. You can say it is a path. A continuous and closed path of electric current is called an electric circuit. So let me explain it. For example, for the flow of water, we have the river. Okay. Similarly, for the flow of charges, we need a certain path. That path in which electric charge flow is called electric circuit. Okay, and for example, see, if this is a cell, means a battery, it gives charge, and this charge flow through this conductor. So what this is a circuit, and this is also a circuit. This is a cell. Okay, this gives electric charge, but in this circuit current does not flow. C-U-R-R-E-N-T, current does not flow. Why so? Because this is a open circuit. OPENCIRCUIT. This is not in your book. You are going to learn this in class 12. So what is an open circuit, and what there are two types of circuit, that is, one is closed circuit and the other is open circuit. What is closed circuit? Closed circuit means there is no breakdown of the path anywhere. In this, electricity can flow start from the battery and end in the battery itself. But here in the next diagram, what you see, electric current starts, but there is a gap here. There is a gap and there is a breakdown. That is why it is not a closed circuit, it is an open circuit, and this is a closed circuit. We are going to learn about closed circuit in this chapter. Okay, and the rest you are going to learn in class 12. So till now what we have studied, what is electric charge and what is electric current and what is electric circuit. And these are the diagrams of electric circuit. One is closed electric circuit and another is open electric circuit. You don't have open electric circuit in your course now, you learn in class 12. Now let us proceed to the next topic, that is how do we express electric current. Electric current, it is a physical quantity. That means we have to measure it. We need to measure it, and to measure electric current we require certain method or a formula. So how does we measure electric current? So for that, electric current, it is expressed by the amount of charge flowing through a particle. Let me explain. For example, let us suppose I have got a circuit. This is a circuit. I have connected a battery here. This is a positive terminal and this is the negative terminal, and I have connected a load, that is, it can be a fan or it can be a light, anything it can be. So if I connect this, current will start to flow. Now, how will I measure how much current is flowing through this circuit? So to do that, if I stay here and mark this point, and if I count the amount of charge flowing through this point at a certain, for example, if I wait here for 5 minutes, and if I, or 5 seconds, and if I count the charge passing through this point in 5 seconds, for example, let the charge passing through this be 2 coulomb. Okay, now according to this, how we measure current? So we measure current by this formula. What is the formula? By this formula. The formula is I is equal to Q divided by T. Now this has come from this definition. This has come from this definition. That is, how do we express electric current? It is expressed by the amount of charge flowing through a particular area in unit time. If you have any doubt, just comment below. I am going to explain, or I am going to clear your doubts after this live session is over. Okay. So again, in another word, we can say that electric current is expressed as the rate of flow of charge. As the rate of flow of charge. Now, what is rate of flow of charge? This rate, when the word rate comes, that means divide. We have an expression where we will find by dividing one item by another. So what rate? If we find the word rate, that means the expression of what we are going to find will have an expression where there will be division of two quantities. And the quantity rate of flow of charge. Rate means the quantity below, or the quantity with which we'll divide, will be always time. And the rate of flow of charge, rate of flow of what? The thing what we say the rate of flow will be on the top. Okay, so and electric current is denoted by the letter I. Electric current is denoted by the letter I. So mathematically, what we can say that electricity or electric current is equal to charge divided by time, Q divided by T. What is Q? Q is the symbol of charge. Once again, I want to explain this term. What is electric current? For example, let us suppose I have a conductor. This is a conductor. If I say that Q amount of charge pass through this conductor in time T, then I say that the current flowing through this conductor I is equal to Q divided by T. Okay, so as we can measure current, so there need to be a unit for the quantity, for a current. So the SI unit of current is ampere, AMPERE, and its symbol is A. For example, kilogram is a unit of length and its short form is kg. Similarly, the SI unit of current is ampere and its short form is capital A, not small a. And remember, the unit always starts with small a. A unit with the name of a scientist always starts with a small letter. Now note, don't be confused by terms I and A. I is current and A is the unit used to measure current. Similarly, Q is the charge of a body and C is the symbol used to denote the charge. For example, I want to measure mass. Mass is the quantity and mass is measured in kilogram. Similarly, charge is a quantity and charge is measured in coulombs. Similarly, current, the symbol of current is I and it is measured in amperes. Okay, so now come to this point, this part. So 1 milliampere, I'll go through this after completing this part. What is this? 1 milliampere. To 1 milliampere means 10 to the power 3 ampere. That means 1 milliampere is equal to 1 by 1000 times of an ampere. Okay, similarly 1 microampere means 1 to the power 10,000 times of an ampere. Okay, this is the smaller parts. For example, kilogram is a larger unit and gram is a smaller unit of mass. Similarly, milliampere and microampere are the smaller units of ampere. Now let us continue with this. Basically, current is the rate of flow of electrons. Okay, now basically what is current? Current is the flow of electrons. Okay, what is current? The name of the chapter is electricity, electric current. Okay, the SI unit, basically current is the rate of flow of electrons. That means the number of, basically current is the rate of flow of electrons. When electricity was discovered, electron was not discovered at that time. When the electricity was discovered, okay, when electricity was discovered, electron was not discovered. And so positive charges were considered to be responsible for electric current. Scientists or philosopher of that time, they thought that positive charges were responsible for electric current. Positive charges. But later on, after the discovery of electron, scientists came to know that no, it is not the positive charge which is responsible for current. It is the negative charge, that is the electrons, which are responsible for current. Okay, so initially when current was discovered, the scientists at that time, it was considered that the direction of current is the direction in which the positive charge flowed. Okay, initially when the electricity was discovered, at that time electron was not discovered, so scientists thought that positive charge were responsible for electric current. So then they made an assumption that the direction of electric current is the direction in which the positive charges flow. But later on, with the discovery of electron, scientists came to know that positive charge, that is protons, they do not move. Only the electrons move. So electrons are responsible for electric current. So, but they did not change the concept or convention. They always regarded that the current move in positive. The current direction of current is the direction in which the positive charge flow, which is in reality opposite to the flow of electron. But even then, our scientists take this as a convention, because there is no changes found, even if we consider that current is due to the flow of positive charge. If you have any doubt, or if you cannot understand anything I say, do comment below. I will follow back, or I will reply, or I will try to clear your doubts after this live session is over. Okay, again, if I speak anything wrong, or any unit, or any for example, if I say this is charge, and if I say this is current, I may speak something which is not correct. So don't mind that. I will try to correct all these things in my later videos. This is my first time I am coming live. Okay, so after this, let us go to the next part, that is Coulomb. Now what is this Coulomb? Okay, Coulomb is nothing, but it is the unit of charge. Coulomb is nothing, but it is the unit of charge. For example, we can measure charge. If we can measure charge, anything that can be measured, it has a unit. Okay, so coulomb is a unit of charge. Okay, so 1 coulomb means there are approximately 6 into 10 raised to the power 18 electrons. Okay, 1 coulomb charge means there are approximately 6 into 10 raised to the power 18 electrons. Okay, and charge of 1 electron is equal to 1.6 into 10 raised to the power 19 coulombs. Okay, so note this down, and I will upload these notes later on, but you, while going through the live session, you please note the things as much as you can. Now, emitter. What is this emitter? So we have learned what is current. Okay, so to measure all the things, for example, to measure the mass, we need a common balance. Similarly, to measure electric current, we need an instrument, and that instrument is ammeter. Okay, to measure electric current, we need an instrument. That instrument is called ammeter. It is an instrument which is used to measure electric current. Now, this is a figure of an electric circuit comprising of a battery, electric bulb, ammeter, and a plug. You need to draw this and remember or memorize or remember it, because you will find this in test or metric. I have seen this question that draw a symmetric diagram of an electric circuit comprising of battery, electric bulb, ammeter, and a plug. Okay, you need to draw this diagram and keep it. Okay, now I'll upload this notes in my WhatsApp group or Telegram group. I'll give the link. You can join that group and you will get these notes. And if you cannot, or later on, you can pause this. I'll upload this live video and you can pause this video and take the notes from there also. Now, there is an example in page number 200. There is an example in page number 200, example 112.1. Okay, so what is the question which is there in page number 2? I have made it simple and written it here. You can go and check your book for this question. The question is, a bulb takes 0.5 ampere current for 10 minutes. That means there is a bulb where 0.5 amperes of current flows through the bulb for 10 minutes. So we are asked to find the amount of charge flowing through the circuit. Find the amount of charge flowing through the circuit. Okay. So many students ask me, sir, how to solve the problem of physics? So we cannot solve the problem of physics. So to solve the problem of physics, first of all, you have to know the concepts and you have to know the formulas of that chapter, formulae of that chapter. Okay. After that, when you get a numerical like this, first of all, you have to read the question first and you have to find the given things. What are the things given in this numerical? For example, in this question, we have given 0.05 ampere, that is current given to solution, given I is equal to 0.5 ampere. And we are given with time, that is t is equal to 10 minutes, and we have to convert that to seconds then, because a second is the SI unit of time. So we have written what are the given things. Then we have to recall what is the formula that is necessary to find charge, that is Q. We have learned that. Okay, I'm sorry. So we have learned that, so after writing the given things, we have to write what we know. We know that is the formula what we are going to use. We know that current I is equal to Q by T. Current I is equal to Q by T implies Q is equal to I into T. Q is what we are asked to find. Q is equal to I by T. Okay, so you note down what you can. Okay, But most important thing is that you listen to what I say. Don't try to note it down without listening. Listen to what I say, then note down as much as you can. And if you cannot note down, I will upload this video after the live session is over. Then you can pause it and go through it. And I will also upload these notes in the WhatsApp group and also in the Telegram channel and group. I'll post the link of the WhatsApp group and Telegram group below. You can go through, you can follow the link and join the Telegram or WhatsApp group. Now, so the formula what we are going to use is I is equal to Q by T, where Q is equal to I into T. So I is given as 0.5 and T is 600. So we get 300 Coulomb. Okay. So when you find the answer, at last you need to give a statement, final statement. Okay. This makes your answer standard in examination. Many students, they do not write a final statement, but if you write this final statement, then you create an impression on the teacher. Okay. So the final statement, therefore the amount of charge that flowed through the conductor is 30 Coulomb. You can make any, you can give your final statement in your words. Okay. Now we are about to finish this session today. We have got only 3 minutes left. So the things which we are going to discuss in the next class are the questions which are in the books, that is, what is an electric circuit? What does an electric circuit mean? We are going to discuss day after tomorrow. We are going to discuss all these questions day after tomorrow. And the second is define the unit of electric current. And the third is calculate the number of electrons constituting on 1 Coulomb of charge. Okay, these are the questions which are in the textbook. They are not solved. We are going to solve this question in our next session. So what we have learned, let us recall what we have learned till now. We have learned okay, let us recall. We have learned what is electric current. Okay, if you have got any queries or any doubt, you can post or comment below. So then we have learned what is charge, then we have learned what is charge, then we have learned what is electric circuit, open circuit and closed circuit. Then we have learned the SI unit of charge and current. Then we have learned how is current calculated, that is the mathematical expression, of electric, that is a mathematical expression of electric current. Okay, so we are about to finish this live session. So do comment any positive word you want. I request you please comment that. And again, in my next sessions, don't try to note it down, try to listen. Then you note it down by pausing my videos later on, and do comment your doubt, and I will be replying to your comments or your doubts, or I'll try to solve your doubts as soon as the live session ends. So thank you very much for watching my video. God bless you.